All right, today we're going to be talking about functions. You have your foldable notes, and we're going to go through each of these 8 flaps. Sounds like a lot, but it's not going to be as long as it looks, I don't think. So first, let's start with the definition of a function. What is a function? A function relates an input value. Oh, goodness. To an output value. Can't remember if I told you guys that I dropped the Apple Pencil tip down on the hardwood floor, and so it's smashed. Now I can only write if the Apple Pencil is pointing, directly up, like perpendicular to the iPad. I can't slant it like I would write with a pencil, so it makes it a little challenging. So each input value, which for our purposes are going to be the x values, is paired with only one output value. And the output values are the y's. So it's kind of a little bit abstract there what a function is. Maybe in elementary school you did those function machines where you put a value in, something would happen to it, and you'd get an output value. It's kind of like that, and basically functions are equations because the value of y depends on what x is. Just like in this case, the output depends on what the input is. And it'll make more sense as we go through these notes. So all of the input numbers, which again are the x's, are called the domain. And all of the the output values, or the y's, are called the range. And one way that I can remember which values are the domain and which values are the range is like this. Input comes before output alphabetically. X comes before y alphabetically, and domain comes before range alphabetically. That has helped me remember for like 30 years. So if I can remember that just all of those things are alphabetical, maybe it will help you. All right, so in this box right here, it's asking us to name the domain and range. So we said that the domain is all of the x values. So 2, 4, 5, and 9. That's the domain, the x values. The y values are the range, and in this case, for these ordered pairs, it'd be 1, 3, 4, and 7. Doesn't have to be listed as ordered pairs. It can also just be in a table. So my domain would be all the x values, 4, 7, 6, 3, and 5. And then my range are all my y values here, 6, 8, 2, 7, 9. So that's pretty easy if they just ask you for the domain and the range. All right, now we should look at how we write functions. We use something called function notation. It's just a fancy way to write a function. We use it using this symbol, and we use it instead of the y. So basically y, and this is called f of x. F of x and y are basically the same thing. So if you have an equation that says y equals negative x plus 2, you can write it in function notation by, instead of writing the y, just writing f of x equals negative 5x plus 2. So it's saying that x is, that the function is dependent on what you input for x. And then you probably heard me say above that we say that as f of x. And you see this, it's called f of x. All right, let's solve some. It's really a lot like just solving an equation. So if we have f of 1, this is called, and f of x is negative 2 minus 8, to find f of 1, we just replace x with 1. So I'm going to write 2 times 1 minus 8, or 2 minus 8 is negative 6. Not as hard as it looked, huh? So if we're finding f of 6 using that same function, we will replace the x with negative 6. So 2 times negative 6 minus 8 is going to be negative 12 minus 8, which is negative 20. For f of 0, we'll replace x with 0. 0 minus 8 is negative 8. And for the last one, if we're looking for f of 100, we'll replace the x with 100, and we'll have 200 minus 8, 192. Beautiful. Okay, so now I have my little flaps down here. So now we're going to determine if a relationship is a function, and you can do that 4 different ways: from mapping, from points, from a graph, or from a table. So this right here is called mapping, where you see these diagrams. So remember what we said up above, that each x value can only be paired with one y value. So basically it means that this 2 goes with the 1, and really that is on a graph the point 2, 1, right? Because the x's are the first number in an ordered pair, and the y is the second number in an ordered pair. So the 2 is paired with the 1. It's not paired with anything else, just 1. The 3 is paired with the 6, the 5 is paired with the 7, the 8 is paired with the 6, and so none of these are paired with more than one y value, so this one is a function. Unlike this one over here, if we were going to list these points right here, we'd have like the 0.65, we'd have the 0.21, we'd have the 0.84, and we'd have the 0.82. Well, you can see that 8 was paired with 2 different y's, so that is not a function. If we look down here, telling if something's a function from a set of ordered pairs, remembering that the y values cannot repeat, basically the same thing we saw up on the mapping one. We have a 1, 3, 5, 8, so this is a function because none of the x's repeated, but 5, 7, 0, 7, we have an x repeating, or an x being paired with 2 different y's, and so that is not a function. It makes even more sense when we look at the graphs. We can use something called the vertical line test to see if the x's repeat. So let me see if I can make a vertical line and move it, if I remember how to do that. I think I just hold it down. Maybe because I ruined my Apple Pencil. There we go. Well, that's not a very straight line, but let's try one more time. Okay, so I think I can grab this maybe by touching the finger. No. I thought there was a way I could move it. I don't remember. I thought I could hold it down and like move it across. I don't know what I'm doing now. Let's try one more time. Is there a way to grab it? Shoot. It's very hard to show on the iPad, but basically if you took that long line and you took that vertical line and you moved it across, no, it's not going to work for me. And you moved it across the graph this way, it could only touch the graph in one place at a time. So if we took that vertical line and we moved it to the left, you can use like your pencil to do that. There would be no place on that graph where it would hit the line more than once. So this is a function. If you took a vertical line and you moved it across this graph from left to right, it would actually touch the graph here in 2 places. Well, in lots of spots, it would touch in more than one place, right? Because the vertical line going through right here would hit that graph twice. Actually, if we put the vertical line right there, it would hit it 3 different places. So this is a no. And of course, doing these notes in class live, I'll be able to show you with a pencil how to move it across and do a vertical line test. So it's a little more clear than it is here, you know, on a YouTube video. All right, so for this last one, using a vertical line test, and moving it across the graph left to right, there is actually no place where it would touch the graph twice. So you might be thinking, well, what about right here? It sure looks like it's going through the graph here and here, but these open circles mean that it does not include that point. So it actually is hitting the graph here, it's not hitting the graph here. So there's no place where it would hit the graph in more than one place at a time if I moved a vertical line across it from left to right. So this one is a function. And lastly, remember what we've said several times now, that each x value can only be paired with one y value. So basically you're looking to see if any of the x's repeat. 2, 4, 5, 9 doesn't repeat. 4, 7, 6, 7, the x's repeat here, so this one is a yes, and this one is a no. When the x's repeat, that's when we have a graph that has, like this one right here. Let me erase some of this. I think I can erase. Yeah, like this, for example, is the point 2, -1. And this right here is the point 2, -2. So see, the x is repeated, which caused it to fail the vertical line test. All right, so that is a real quick rundown on functions to get you started with the new stuff we're learning. Thanks for watching.